This is problem number 4 from the 1.4 topic questions. We have a plane traveling from A to B or B to A. They give us the airspeed, they give us the air, they tell us that sometimes there's air moving at a certain velocity, and then they tell us it takes a certain amount of time to go from A to B. So I'm going to help my brain a little bit by just drawing a sketch. And I've got A to B. I have a plane, toy plane, that flies this way. And then they give me 3 times, right? T0, T, A to B, and T, B to A. And they tell us what the wind is doing. The only difference between the 3 is which direction the plane's going, as well as what the wind is doing. So the key to this problem, I mean, it's no surprise, it's relative velocity. You know that because it's 1.4. But if you look at the system, they give you some velocities, and the key to the problem is understanding what these terms mean. So the first hiccup is if you interpret airspeed, when you tell me the airspeed of a plane, if you think it's relative to the ground, it turns out that's not true. So if you think about it, I'm in a plane. What's the simplest way for me to figure out how fast the plane is moving? Well, if I can sense something about the air around me, like maybe how fast it's blowing over my wings, right? That gives me my airspeed. So it turns out the airspeed VP is the velocity of the plane relative to the air that it's flying in. And then when we say the air is moving, that's the velocity of the air carrying the plane, how fast it's moving relative to the ground. So that's kind of the key to this problem. And to solve it, we can also practice using our relative motion math model. So I'll do that. Our basic equation that we can memorize is the velocity of A relative to the ground is equal to the velocity of A relative to another object plus the velocity of that object relative to the same frame of reference as this guy. Okay, VA equals VAG equals VA plus VAB plus VBG. These are vectors, but luckily we're talking about motion in one direction, so I don't have to worry about components. So the addition is pretty straightforward, right? I don't have to break any of the vectors up into 2 components. Okay, so one possible takeaway or something to extend past this particular problem is if you want to use this math model, what's critical is associating the objects in your system to these subscripts in the math model. And it can get tricky because I've got AB here. Then I've got a P but no second letter, right? So what it turns out, if I want to take this math model and map it to this system, airspeed is really the velocity of the plane relative to the air. Now, I know what you're thinking. I probably would have done the same. Air, that's got to be A. No, don't do that. Try not to use the same letters for the objects in your system. So instead, I'm going to use wind. Okay, so the velocity of the plane relative to the air is really the velocity of the plane relative to the wind, or where wind is the air that could be moving. Okay, so I've got the velocity of the plane. So I'm going to go VP corresponds to, or that's the value of my velocity of the plane relative to the wind. When we say the air is moving, that's got to be the velocity of the wind relative to the ground. Once you've got this set up, you have to start matching it up, okay? And hopefully you could see I've got 2 objects here, no frame of reference, right? Plane relative to the wind. Which one here does not refer to the common frame of reference? This guy. So I'm going to take this and I'm going to customize it for my system. I'm going to say that's got to be the velocity of the plane relative to the wind. Then you use the sequencing to figure out which one this is. Is this AG or BG? Well, it's got to be BG because in this system, or in this subscript, with these subscripts, my B corresponds to the W. So this B has to be WG V plus, that's got to be the velocity of the plane relative to the ground. Why is that important? Well, if you think about the amount of time it takes for the plane to go from A to B, that time depends on which speed. These all depend on the velocity of the plane relative to the ground. Why is that? Well, because I'm going from A to B. A is B, that's the ground, right? I'm on the ground. I mean, A and B are stuck to the ground. So if I want to move from A to B, how fast it takes me to do that depends on how fast I'm moving relative to the ground. So the key parts, we've now got all the key parts figured out in terms of leveraging the math model. All our subscripts have been identified, and we've picked ones to match up to our physical system. Okay, so what's happening now with the different times? I'm going to keep drawing underneath here. And in the situation where it takes me t0 seconds to go from A to B, what do we know? We know that there's no wind blowing. So in that case, the wind relative to the ground is 0. It's not moving, so it's got no velocity relative to the ground. Well, that's easy now because how fast I'm moving relative to the ground is exactly the same as my airspeed because the air isn't moving. Okay, what about the next one? TAB. That one, the problem states that the wind is blowing against me, so it's blowing to the left, and the plane's going this way. It's blowing from A to B, but the wind is blowing from B to A. So how do we match that to this equation? Well, in this case, the velocity of the plane relative to the ground is going to be the velocity of the plane relative to the wind, which is what? It's actually VP. Ooh, I should just put this here. That's just VP. In this case, the velocity of the plane relative to the wind is still VP, and is it plus or minus? I'm going to define this as positive. Right? So when I'm going from A to B, I have positive. Well, in TAB, the time to go from A to B is VP, because I'm going from A to B, positive, but the wind is going the other way. So my velocity for the wind relative to the ground is now minus 1/2 VP, because the wind's blowing at that speed, but against me. Well, that means my velocity relative to the ground in this case is going to be VP minus 1/2 VP. I'm going 1/2 VP. That's the magnitude of the velocity of the plane relative to the ground. Actually, I kept velocity information. It's more than magnitude. If VP is a number, it's positive, right? Because I'm going to the right. For this last one, VBA, what do they tell us? Well, I'm still going VP, that's my airspeed, but now I'm going this way, from B to A. So that's going to be negative VP. And the wind is still blowing from B to A. So that's going to be plus minus 1/2 VP. What's that give me? The velocity of the plane relative to the ground in the last situation, when it took me this long to travel, is minus 3/2 VP. But the time it takes just depends on my speed. I'm not worried about the direction. And you can see that in this case, the plane is moving the fastest because it's 3/2 VP in terms of speed. Here it's moving the slowest because it's only half. And in this case, it's the medium, right? Medium or middle. So which one will take me the longest? This one. So TAB is the longest. This is going to be the biggest number because I'm moving the slowest. This is going to be the fastest, and this one's in the middle. And if you just rank them, I think the question had them in longest to shortest time. So the longest time is TAB. The shortest time is TBA. And the middle time is the middle one.